Welcome to Get Your FRQ On. In this tutorial, I'm going to show you how to use your calculator to solve initial value problems using definite integration. So before we begin with this, let me just review for you the fundamental theorem of calculus. For definite integrals, the integral from a to b of f of x dx is the antiderivative of f, or an antiderivative of f, evaluated at b minus the antiderivative evaluated at a, and we are here assuming that a is less than b. And the way that this relates to initial value problems is, for an initial value problem, you're typically going to be asked to use the value at the beginning of an interval to calculate the value of a function at the end of an interval using the integral of a rate function, or using the initial value of the function at the end of an interval to calculate the value of the function at the beginning of an interval using the amount of change given by the integral of that rate function. So if we know the value of the function at the beginning of the integral, we take the value at the beginning, add to that this definite integral. Remember, that definite integral represents the total amount of change. So if I have beginning amount plus all the change between the beginning of and the end, that should get me the ending amount. Or in the second case, where we know the ending amount and we want to figure out some value before it, we can start with that ending amount, subtract off all the change that got us to that ending amount, and that would tell us the amount that we started with. Right, so you could see both of those on the free response questions on the AP exam. Just make sure that you understand it's two slightly different formulas, but they all come from the statement of the fundamental theorem of calculus. All right, so I have this function stored in y1. It's a nasty function. Not going to want to do that by hand. Although for this one, you probably could do it by hand. There's nothing terrible about this. So I'm going to exit out of here, and let's say that we have an initial value of this function when x is equal to 0. The value of the function is 7. Right, now in this case, my y1 function is the rate function. Right, so if I wanted to figure out, say, what is the value of my function at x equals 1.5. Right, well, my initial value in x is 0 was 7, and then I would just add to that the integral from 0 to 1.5 of this function, my rate function, which is y1, dx, and this would tell me that the value of my function when x is equal to 1.5 is 15.554 and whatever. Likewise, let's say in a different example, we're not using this initial value anymore. Let's say that the value of the function at x equals 2 is negative 1. All right, then I could just do, well, okay, negative 1 minus the integral from, I don't know, let's just do 0 again, 0 to 2. I think I said 2, right? So this would be where I know the value at the end of my interval and I'm trying to find the value of the function somewhere before that. So basically I would just take that initial value and subtract off all the change that got me there. So in this instance, if big F of 2 is negative 1, big F of 0 would be negative 11.419. Right, so that's how you can do initial value problems on your graphing calculator using definite integrals. Again, this would be useful on some calculator active questions. You're not allowed to use a calculator on calculator inactive questions, so I would not recommend doing it this way, but if you can use it, that's how you would solve those IVPs.